Hello, I'm Kirk with AdoredTV. Today we are going to be building a network media server. As you can see here, we have all the parts laid out for our new system, and we are going to be replacing an old system that has actually ran out of space. There we go. In this guy, we have some more modern equipment here with an AMD processor and video card and such, but it's drawing a little bit much power. We have 8 hard drives in here, but they're only 2 terabyte. And so while the equipment is pretty modern, it had been recently replacing a Pentium 4 based Xeon. We actually are running out of space. We have 8 hard drives that need to be upgraded. So let's go over the new system. We're going with a Ryzen 5 3400G. It has an iGPU, should save us a little bit of power there. It's a little bit of a step down from the 1700X that's in the old server, but there's only going to be a couple users in the home network, and so they're only going to be streaming a couple of media items and accessing files, so the compute isn't as necessary. We have a B550 motherboard here from ASRock. This is a fairly affordable Pro 4. It has 6 SATA ports, which is the important part because we're going to be running a software RAID. And we actually have an additional expander card here. This is basically an LSI 9211 8-port internal card. It's a rebrand. It's from HP. So we have our hard drives. We are going to be doing 7 Western Digital Ultrastars. These are from 8 Western Digital Ultrastars. 9, 10, okay, 12 Western Digital Ultrastars. These are rebrands from when they bought Hitachi. So these are the helium-filled drives, and they're the enterprise class, so they have a great warranty on them for 5 years. Then next up, we have our power supply. This is an EVGA G5. It's a 650 watt, should be more than enough for our needs, and it comes with a 10-year warranty, so that's actually very important. You can check out our write-up on picking your own power supply on our website. And then we got some thermal paste. These are actually for the RAID card. These are a mini SAS to SATA fan cable. So we got 2 of them because of the 8 internal SATA that we'll have. And some SATA to Molex adapters to power the backplane. We have a 500 gig Western Digital Black NVMe drive to power the OS and handle the metadata for our media. And then we have 16 gig of G.Skill RAM. Now the case that we chose is actually a Rosewool case. This is actually the same case that the old server is in, except for this one comes with hot swap capability. So when we have a hard drive failure, we can just pull the drive out from the front and replace it with a new drive, slot it back in, and have our RAID rebuild so that we don't have to tear the whole thing down and disassemble this portion in order to get the hard drives out. So for the OS, we're actually going to be running Linux, and then we're going to run ZFS on Linux for the RAID. Now we had plenty of other choices out there. There's FreeNAS, which also runs ZFS, but in order to do things like Plex, you have to run those inside of a gel, and that's not always the easiest for beginners to set up, especially people unfamiliar with Linux. And so this one, we actually want a little bit more dynamic capability to the server. So we're going to be running normal Fedora Linux, and that way we can do things like containers, gels, and all that just as we would with Unraid or FreeNAS. but it also gives us the capability of doing plenty of other things with the system as well. So with that, let's go ahead and get our build going. We'll start by mounting our fully modular power supply. Just get it in here. We'll need to adjust the standoffs to match our motherboard. A 3/16 socket works well for this. You can remove this bar that's in the way if you need. I'm just going to leave it here. Make sure you get all of these standoffs in the right place. Then make sure the I/O shield snaps into place like this. Make sure it's all the way in. There we go. And then just slide the motherboard in. Make sure you get all of the screws secured in place. Especially this one hiding back here alongside the I/O plate. Lift the retention latch and place the CPU in. To mount our stock cooler, we have to take the existing plastic mounting off. Then we just screw in the 4 screws into the back plate in an alternating pattern and check for tightness. And there we go. Then plug the CPU fan in. I'm just going to tidy this up a bit. Then slot the RAM into the recommended DIMM slots. Be sure to check your manual for this. Just kind of a rocking motion. They snap right in. Now we plug in the motherboard's CPU power connector and the main power connector. We'll just use the Velcro strap provided by our EVGA power supply to clean this up too. There we go. The RAID card came with a low profile bracket attached. We just need to unscrew 2 screws to swap it with the full-sized bracket that was provided. Let me remove this back guard, pop this into place. There, and screw it down. The rear fans chain together with Molex connectors. We'll use a SATA Molex adapter to power these, since we're very limited on the number of Molex connectors. Next, we take the M2 heatsink off so that we can mount our NVMe SSD. These screw heads are small and require a precision screwdriver to remove. We have to screw in the required standoff depending on our M2 length, then slot in our drive at an angle and lay it down to secure it with the screw. Remember to take the blue protective film off of the heatsink before we screw it back into place. Now we'll get our Molex adapters and Molex cable in place and tidy it up just to keep the cables out of the fan blades.
Next, we'll plug in our first group of SATA cables. We'll attach these to the motherboard since the cables are long, and we'll use the first 4 SATA ports as the last 2 are shared with an M2 slot in the event that we want to use that M2 slot in the future. Take the protective caps off the end of the mini SAS to 4 SATA cable and plug them into the RAID card. They're labeled P1 through 4, so I'll be picky and just plug them in order. Now the USB headers and front panel connectors. These are labeled on the board, but you can check the manual as well. The drive caddies just unlatch and slide out easily. Then we just place our drives in with the I/O towards the rear and then screw them in. Just 4 screws in the 4 corners.
Now when you're putting the hard drives in the trays, be sure to label the trays with, in my case, the last 4 of the serial number on the hard drive. Because the last thing you want to do is when you're having a drive fail is to pull the wrong drive. So you want to be 100% certain that you're pulling the right drive when you're replacing one of these.
Now let's see if it boots up. Huh? We got a splash screen. Oh no.
And it sounds like we have one failed drive. Let me see if I can get a better audio for you.
So it's for sure coming from this particular drive. After troubleshooting, I discovered 2 things. 1, the drive works properly when directly attached to a SATA cable. And 2, that a bit of upwards pressure would make it stop clicking and work properly. We'll just swap this drive with its neighbor since it's likely a seating issue with the bay. And it's fixed. Now onto the software side of things. Rufus is a tool used to generate bootable USB images. We'll just download the latest 3.13 version. Next, we'll need to get our preferred Linux distro, Fedora 33 Server Edition in this case. We'll grab the standard ISO instead of the net install, so we'll have all the packages on our USB drive. When it's done downloading, we can launch Rufus with our USB drive plugged in, select our Fedora ISO image, label our USB as desired. Fedora Server 33 x86-64 is a bit less convoluted. Then just go ahead and click Start. You'll want to hit Yes to download the compatible syslinux files for this particular disk image. For this, you can go ahead and just pick the default of Write in ISO image mode. Then we'll get a warning that will nuke all the stuff on our USB. That's okay. This part may take a while, but I've sped it up a bit for us. Back to our server. We'll jump into BIOS and load UEFI defaults. We'll set the RAM to the XMP profile, which is DDR4 3600. CPU configuration looks good. Onboard devices, we set restore on AC power loss to power on. This will allow us to use a smart plug to remote hard reset our server if it locks up, and provides a quick power on after power blips if you don't put it on a UPS. And please, please, put it on a UPS. Just do it. Next looks like only 2 of the 4 drives connected to the motherboard are showing. We'll need to go and reset those 2 drives as well. Great job, Roswell, on the back plane. Yeah, so enable SATA hot plug so we can hot swap failed hard drives. ACPI looks good. Super IO. AMD CPU options. I'm just going to turn off aggressive SATA device sleep, just to be safe. Temps look good. Make sure secure boot is disabled. Double check the boot priority for the NVMe. Save changes and exit. And done. And it boots straight into BIOS. Not good. Oh look, the RAM is still at 2133, so the XMP profile didn't take. We'll just drop it down to DDR4 3200 and try again. And there we go, on a Linux installing. So much waiting to initialize. Oh, sorry, camera. Yes, English. Here's the customizations for the install. We'll check the installation destination and pick the NVMe drive. We'll leave it as automatic mode for the layout. In software selection, we'll leave the Fedora Server Edition selected. These are all the clusters of software we can install for our server. We'll pick editors for Vi support. Headless management gives us text-based system tools for system management. And system tools for SMB, and we'll pick text-based internet as well. Next, we could set up the NIC, but it's already set for on and DHCP, so that's fine for my network for now. We'd want to set this to static if we're deploying it here on my network though. We'll set our root password. The installer will tell you if you have a reasonably good password. Since I may have to remote support this server, we'll add ourselves a support user as well. And begin installation. This part used to take forever using DVDs. If you have a good USB, it can fly by pretty quick. Increasing playback speed by 2500% helps too. While that finishes, we'll jump over to download PuTTY. This is a secure shell program that we'll use to configure our server. We'll just run through the installer as usual. Just accept the defaults is fine. And just punch in the IP address and accept the certificate thumbprint. Then log in as our support user. We'll need to switch to the root user to gain full admin privilege. Now let's go ahead and list devices. We can see SDA through SDL, so that's 12 devices, meaning all of our drives are showing up appropriately. I wrote a quick bash script called list serials that just reads the serials for each drive from its smart data. I'll have this and other helpful scripts in the write-up on AdoredTV.com, which will accompany this video, so be sure to check that out. So first things first, with a new system, you'll want to do a DNF update. This will go through and make sure our Fedora server is completely up to date with the latest patches. And yes, this may take a while. We don't have much installed, so there's not much to update. Let's make sure we have ZFS, which apparently we don't. So let's go ahead and install ZFS in PHP. I like to use PHP for advanced scripting. ZFS isn't in the default Fedora repository, so we'll have to add the ZFS repository for Fedora manually. The steps to do so are on OpenZFS's GitHub, which I'll link in the description below. We first installed the ZFS release RPM, which conveniently adds the ZFS repo and gives us the public signing key to verify releases for future updates. Now we can go ahead and actually DNF install ZFS. And there, now we have ZFS. At this point, we'll want to create our ZFS data pool. So we issue a zpool create command. We want to do an option A shift equals 12. This will do a byte offset for 4K sector sizes. We also want an auto expand option, as well as an auto replace option. What auto expand does is it will allow us to replace existing drives with larger sized hard drives. And once all the drives in the array are replaced, the extra capacity will just automatically become available. For instance, in our 8 terabyte array, if we replaced a fell drive with a 12 terabyte drive, that extra 4 terabytes wouldn't be available for use. But once we've replaced all of the drives in our array with 12 terabyte drives, the pool will automatically expand and the extra 4 terabytes per drive then becomes available for use in the pool. With auto replace on, if a drive has a failure, we'll just pull the drive out of service and we can put in a replacement drive into the same slot and it will automatically be formatted and added into the pool. When a ZFS pool is repaired from parity, this process is called resilvering. We'll name the pool Media and make it a RAID Z2, which is equivalent to a traditional RAID 6. Now this is where we add all of the drives. What I like to do is add the disks by ID. You can see all of the drives we have here. They're all the same type, so the beginning portion of the ID is the same, which is why tab complete listed them all. We have all 12 showing. It has the drive manufacturer, the model number, and the serial number all in one ID here. So it's a lot easier to find them when you run zpool status, and it shows which drives have failed and which ones are impacted, and it shows you this by ID number because we added them by ID number. I've overlaid what it looks like when we have this pool all set up. Let me just get all of these drives typed in here. That should be all 12 drives, so let's go ahead and create it. ZFS modules not loaded. We'll just run the suggested sbin modprobe ZFS command to load them in then. And there we go. ZFS modules by default only load if the kernel detects a ZFS volume that it needs to mount. And you can run a command to have those modules automatically load regardless if a ZFS volume exists or not. I've included this command in the video description as well. We can run zpool status now, just to make sure we have all of our drives in there. Yep, all 12, identified by ID. Zpool list shows us our ZFS pools. Our media pool is 87.3 terabytes raw. And ZFS list shows our sub-volumes in our pool, which is currently just the root of the media pool, as well as our actual usable volume capacity at 64.4 terabytes. ZFS get all media will show all of the options for our base media pool, among which is compression and dedupe. Compression is currently turned off. If you plan on using this for data storage, for documents and other things that are compressible, we could just turn it on for this volume. Since this will be primarily a FLAC, JPEG, MP3, MP4 file type repository, compression will be automatically skipped for those file types anyway. So it actually wouldn't make any difference for us technically, so we won't bother turning it on for this volume. If you make a sub-volume that you want to store data in, you can individually enable it for that sub-volume if you'd like though. Now we can create our desired sub-volumes. We'll ZFS create media Plex first. You'll see it made a new Plex directory for us. You can put TV shows in there, as well as movies. Now we can create our pictures sub-volume so that we can have all of our family photos and things like that in there. And we'll put some anime in here. Sure, why not? Now we have these sub-volumes which can easily be individually managed with our options or snapshots, but that's outside the scope of our project here today. But we now have our general setup here. One thing we still need to do is install our Plex Media server software on here. You can download it from the Plex.tv website. We've already signed up for a free account. We'll go ahead and download the media server. We'll do that on Linux. We're going to do it on Fedora 64-bit, which will download an RPM package. You can FTP this file over to your server, but I'm just going to copy the URL and grab it with wget directly from the server. We'll run rpm-i to install the package. There we go. Next, we'll want to allow the Plex service port through the firewall. Currently, there are no allowed ports. We'll need to add port 32400 TCP. Now we'll just make it permanent. There. We'll enable the Plex Media Server service and start it. Quick PS command and you can see we have it running. To claim the server and set it up initially, you just go to the IP address, port number, and /web. So that's :32400/web. Make sure it's HTTP and not HTTPS. And go ahead and hit enter. And now you go through the setup process. You can choose to do PlexPass or not. And then you can give your server a name. Now we add a movies library. We'll put it in our Plex movies folder. And then we'll make TV shows. We'll make that pointing at our TV shows folder. Then our pictures library. That's pointing at our pictures folder. Something I like to do is make subfolders for anime movies and TV shows. Now we add another movies library that points at anime movies. And TV shows for anime TV shows. And there we go. These are all the streaming movies that Plex provides automatically, as well as featured channels, film, and TV. You can remove any of these that you want at any time. You just have to go up to your side menu here and then unpin them. It's up to you. We don't have anything added to any of the folders here, nor have we even claimed the server yet. We can just click here to sign in and claim our server and start uploading our files. Then we click here and scan our files to detect them. Something we can do as well is we can edit our library and go into advanced. And here you can do all these different things such as having video preview thumbnails, find extra content, prefer local metadata if present, cinema trailers. You can adjust the scanner and agent used to pull the metadata for the content. You can pick where you'd like to have your rating source come from. Rotten Tomatoes, IMDb, movie database. You can take your pick. We'll just do IMDb. One thing I like to do is actually turn off the video preview thumbnails. If you have a large video content library, this is just going to fill up your hard drive. Having a thumbnail every 3 seconds as you scroll through a movie takes up a lot of space. If you accidentally left it on, you can purge all of them using this button here. We're going to disable that for each of these other libraries as well.
All right, there we have it. We have our media server ready to be delivered. With the amount of space that we have on here, 12 drives at 8 terabytes each, we have about 65 terabytes usable in a RAID Z2. And so he can withstand up to 2 drive failures and still be operational. That should give him plenty enough time to get a replacement drive in without actually having to keep one on site. And with the amount of space, that means you can store, roughly 14,000 hours at 10 MIP. That's quite a lot of B-roll footage for us, for sure, but this is going to be one pretty good media server. But thank you for watching. Be sure to like and subscribe for more videos, especially these how-to build videos, as well as our news coverage. Check out our website at AdoredTV.com. And we will see you later.